I'm on section 6.5, 6.5, question number 41, page 515, 515 of your pre-calculus textbook. The credit goes to Stewart, Redlin, and Watson, the authors of this textbook. There's a really nice drawing on that page that I do invite you to go ahead and look at it. But the gist of it is that here's the sun. And around the sun, we have Venus that is moving around the sun. Please pretend this is a perfect circle. I know it's not, but pretend it is. And farther, here's the Earth, way down here somewhere, going around. And the author wants us to, so let's say when Venus is some point in the textbook on the picture, Venus is somewhere around here. Let me do a different color. And then it rotates and goes somewhere then in here. Okay. And what is asked from us? It is asked from us to find this distance right here. Okay. And once it's long, big distance, and the other time this shorter distance right here. So let me go ahead and it's given that this distance between, let's say, the sun and Earth right here is 1 astronomical unit. So just 1 astronomical unit. What else is given to us? It's also given to us that this angle right here is 39.4 degrees, 39.4 degrees. And one more piece of information that the textbook says that the distance from Sun to Venus is 0.723. So this distance right here is 0.723, 0.723 astronomical unit. And since this is presented to us as a circular motion, then I can go ahead and say that, okay, this is 0.723, 0.723. So now, using basic geometry, I can say that this side is congruent to this side. So therefore, this angle is congruent to this angle. And once again, what's the question? The question is telling us that find this big distance, d, from this position to Earth. And the next time when the Venus is rotated, find the smaller distance between the second position of Venus and Earth. Okay. It's going to be really hard for me to explain this with one drawing because the numbers are going to get really jammed. I'm going to go ahead and use 2 triangles. So one's for the larger distance. I'm going to use something like this. Let me just go ahead and to the next page and just do it from there. So I'm going to go ahead and first use the larger looking triangle, something like this. When the Venus is in its first position, something like this. What do I know? I know that this is 0.723. I know this is 1, and this is going to be 39.4 degrees. I'm going to go ahead and use law of sine to find this angle right here. Let's call that beta. Okay. So now I can say that sine of beta over 1 equals to sine of 39.4 degrees over 0.723. Okay. So beta equals to sine inverse of, multiply both sides. Okay, now if I divide both sides, so sine inverse of sine of 39.4 degrees divided by 0.723. Okay, and so sine inverse of sine of almost equal to 61.4 degrees. So this is 61.4 degrees. Okay. Well, if that's the case, okay, if that's the case, now I have, then what is this, my angle, the third angle here? I can say 180 subtract 61.4 minus 39.4, and that gives me 79.2. So 79.2 degrees. Okay. And remember that I'm going to find this distance right here. Okay. And so I have d over, or sine of, change color, sine of 79.2 degrees over 39 over d equals to, okay, sine of 61.4 degrees over 1. Okay, anything over 1 is itself. So d equals to sine of 79.2 degrees divided by sine of 61.4 degrees. Let's see. So I have sine of 79.2 and that gives me to 1.1187. Let's just go to 3 decimals. And so I have 1.119 AU. 1.119 AU. So that's the larger distance. So let's go to the next page and take a look at the smaller distance and see what we can do with that. So go to the next page. Okay, for the smaller triangle, when the Venus has moved, I'm going to have a triangle, something like this. Okay, and this still right here is 39.4 0.4 degrees, and this still is 1 astronomical unit. I'm going to do a little bit of with different color. Let me just continue to just use what we found for the in previous page. Remember, in previous page we found out, we said that this side right here is the same, congruent to this, so they are the same. Therefore, this angle right here is the same as this angle. So congruent to that angle, so they're both, we found out that were 61.4 degrees. 61.4 degrees. Well, if that's the case, how much is this angle? Remember that these two angles together, this two angle 61.4 degrees, and this angle right here should give me total of 180. Okay, so if I say 180 minus 61.4, that gives me 118.6. So here is 118.6 degrees. And so look at the blue triangle. For the blue triangle, what is this angle right here? This angle right here is 180 minus 39.4 minus 118.6, and that's 22 degrees. Okay, 22 degrees. Okay, and in this part of the problem, I want to find this distance right here. So I can say that this distance, let's see, this distance over, well, let me just do it like your textbook does. Let me just sine of sine of 118.6 degrees over 1 should equal to sine of 22 degrees, sine of 22 degrees over my d. Let's call this one d. Well, 118.6, sine of 118.6 over 1 is just itself. So I'm going to say that d equals to sine of 22 degrees divided by sine of 118.6 degrees. So distance approximately equal to sine of 22 close parenthesis divided by sine of 118.6. And that gives me, oh goodness, 0.4667 and on and on. Let's go to 3 digits again. So distance is approximately 0.4. Ooh, I dropped the 2 in here. I'm so sorry. That was 0.42666. So 0.427 astronomical unit. I hope you enjoyed this video, and I hope you find it helpful. Thank you.